All right, so procedurally generated worlds are ones where we build the world from a script. In this example, I have a relatively dumb maze generator. This just loops over a checkerboard of grid of the world, placing or not placing a wall object based on a random value. So it's going over the checkerboard, throwing a random value, and instantiating a wall object there. If I happen to not have a player, it'll spawn one for me. And in fact, I don't think I have a player in here. I think all I have is the NavMesh object, uh, NavMesh surface, and my level generator that has the player, the marker, and the wall modifier here that it's going to instantiate itself. I've got probabilities and a random seed just so that I can make this reproducible. But I don't have the maze here. When I run this, the maze is generated. So it using random numbers, drops these different walls around the world. Uh, these are the different walls. The objects that I'm dropping here are ones that have a NavMesh modifier component on it. We could just use a regular chunk of wall that is set to be NavMesh static, and it will achieve the same effect. The NavMesh modifier gives us a little more control over this in the sense that the NavMesh modifier has an area type that I can specify, and also what agents are affected by it. The modifier affects hierarchically in that if the game object has children, they're affected by that. So a complex object with children, all of the children would be affected by the modifier. And the modifier affects the baking process, which has to be updated to reflect any changes. If you were to instantiate one of these during gameplay, you would have to rebake the mesh. Parameters, ignore from build. Basically, it's skipped. We can override the area to be a particular type. In this case, I've overridden it to be a not walkable area. And if we do override it, we specify the area type. And we can also select different kinds of agents that the modifier will affect. So later when we see a different kind of agent than our humanoid, uh, 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 we can affect them separately. So the other thing, you notice there, when this isn't running, there's no nav mesh, and it's only when I run it that it actually throws the objects down and bakes this mesh, and bakes this nav mesh that we can then navigate on, and it follows these little things around exactly the way we want it to. One other thing before I go on, this area type, different areas can have different costs to travel across. For instance, if you were modeling a swamp area or a place that was a hard slog across, or going through some place that was on fire that would damage our character. Um, um, in the NavMesh calculation of what the shortest path is, the algorithm takes into account the cost of traversing an area, not necessarily the distance only, but the cost. There are three default areas. There's the walkable that costs 1, there's the jump that costs 2, and there's the not walkable, which I suppose is infinity since our character can't traverse a not walkable area. And there are plenty of others that we can define, plenty of other nav mesh areas that we can define in our area settings. There are 32 of them. Here I've got a fire setting that has a cost of 500. So that's going to be a very expensive one to cross. Not walkable is the same as putting a NavMesh static object there. And I have an example of that if you're interested in it. Now, there's another similar device that's the NavMesh Modifier volume. And this applies its specified area, its cost area, to the surfaces enclosed in that volume, rather than to the object, the simpler modifier effects. So in this next case, I've got my level generator here has the wall with high cost object, which actually is an object with no collider. The mesh renderer is turned off. I'm not seeing it, but as a child, it has a complex fire, so that this is a region that is on fire, supposedly. The other thing I've done here is the fire object has a box trigger set to is trigger, and it's going to subtract points from my player when on trigger stay is activated. And so my character will avoid the fire because it costs a lot to traverse it. But if there's no other way around, it will go through the fire and experience some pain. So here's my current score. There's this checkerboard of fire around here. If I ask it to go someplace that it can get to without going through the fire, it's very happy to do that. I'm not sure. Yeah, it'll go around. But if I ask it to go to this spot in here, it's going to go through the fire. But you notice it cost it something to go through the fire there because fire is expensive. It looks for the easiest way around. There it only is going to go through one batch of fire and another batch of fire to get there as it loses its points. I haven't shown you how to bake the NavMesh, which is in the NavMesh generator in this level generator script. I'm not sure why it's not showing up in the notes, but I'll quickly go in here into the level generator. Because as it throws this checkerboard of points, as it throws its checkerboard of points, that's the generate level. Once it's generated that level, it's going to then take the NavMesh, which is the NavMesh surface, this thing over here, and it's going to build the NavMesh. It's all we have to do. It does it automatically. It's not something we have to write. So this is pretty simple. And that's how I did all of those examples there. Now, the NavMesh links. Links. So here I have two separate NavMeshes, and I've pre-baked these, and I've included here a link between these two. The link is a little object. We can move it around, and we can change its length, and in particular, we can set these little landing spots where it's going to drop the character. It's going to jump over this link. There are various settings here. Let me go back to the defaults here. We can set the start and end point of the link, the start and end point. We can move them up and down, forward and backwards, right and left, and we can specify what kind of agent can cross it. The link has a width. If I make the width bigger and make this, you can see the width of the link here is now wider. This just has to do with how narrow a path it is across that thing. So with this, if I click over here, it goes across the link, and it can't cross anyplace else here. It can only cross on the link. And these are things that we can place around our scene. And this is actually how I did this one. This basic with links here, I set up these various links to jump from one surface up to the next. And it's worth having a look at how these are set. This one starts at 0, 0, and its endpoint is at 0, 1.14. So it's jumping up onto something here. It jumps up onto this surface. So one end of the link is here, and the other end of the link is up here. I have some scenes with what I called an odd bug. They seem to have disappeared, so I won't bother with them. The links don't have to be at the same level. Here's links at different levels. Now my NavMesh is jumping up from this thing, so it's gonna quite happily jump up this link or jump down the link. And so we can make these fancy links. We can do really fancy things. We can, here I've built two NavMesh surfaces. One that is kind of the floor, well, this one that's the floor, and this one that's the wall. And because they're childed, the NavMesh surfaces are now not necessarily horizontal. And so I can do really strange things here, like have him jump up onto the wall. And notice the NavMesh agent reorients itself so that it's perpendicular to its NavMesh. This is kind of a strange effect, and I'll show you another example of this later. I'm going to stop sharing here. Right now we've been using this little cylinder for the character, but of course we'd really like to have an animated character, and I'll show you that in the next scene and the next video. So I'm going to stop recording here, and I'll see you all in class.